In this video, we want to take the limit as x approaches 0 of 1 plus x times 2 to the x over 1 plus x times 3 to the x raised to the 1 over x squared power. So in order to solve this, we have to use the fact that x is equal to e to the natural log of x. So instead of taking the limit of whatever's inside, we're going to take e to the natural log of the original limit. And now, one of the properties of the natural log is, well, if you have ln of x to the n, the exponent comes out in front and multiplies the natural log of x. In this case, the exponent is 1 over x squared, so that's going to come out in front of the natural log, like this. And so I can rewrite this as e to the limit, so basically switching spots e in the limit. And I can do this because e is a continuous function. So I'm just going to do e to the limit of this thing. And the purpose of doing all this is to show that, well, if I plug in x equals 0, I get ln of 1 over 0. ln of 1 is 0, so it's just 0 over 0. And so I can use L'Hopital's rule, which means I have to take the derivative of the top and the derivative of the bottom. So the derivative of x squared is 2x. The derivative of the natural log of the inside is 1 over the inside. So when I take the 1 over the inside, that's basically the reciprocal, which means the numerator and denominator are going to flip. And then I take the derivative of the top using the product rule times the bottom. So I'm going to just call the top f, the bottom g. This is f prime, and this is g. And then minus the derivative of g times f. And that's going to be all over the bottom squared, which is the 1 plus x times 3 to the x. Now we simplify. We know that 1 plus x times 3 to the x will cancel with one of the factors here. So I'm left with 1 over 1 plus x times 2 to the x. And now I can bring everything in the denominator. So I have 1, I have 2, and then 3. This denominator is going to go in with the other 2. So it's going to multiply the 2x. So 2x can multiply 1 plus x times 2 to the x and 1 plus x times 3 to the x. Because the idea is, if we call the top a and the bottom b, if I do a divided by b, that's the same thing as a times 1 over b. So 1 over 2x will be multiplying the denominator. So now I can FOIL things out in both of these. And what I did was I kept the negative out here, so I just FOILed out these two and just kept the negative. And so now I would just have to distribute the negative. So distribute the negative to everything. And you end up getting this right here. And I highlighted the ones that are going to get canceled in red. So then that simplifies to this, which I can split up into two separate limits. So one of the limits is going to have 1 as a numerator, and then 2, 1 plus x times 2 to the x, and then 1 plus x times 3 to the x. That's for the first limit, and then everything else will be in the second limit. So that's going to be x remaining in the denominator with everything else in the numerator. Okay, now I can plug in x equals 0 here. So this will be 0 times 1, and then this is 0 times 1 as well. So this is just 0. So it's 1 over 2 remaining. So I just factored that out in front of the limit. And then now all I have to do is just solve for this limit right here. And for that, I'm going to use L'Hopital's rule because I get 0 over 0. So I take the derivative of the top and the derivative of the bottom. So the derivative of x is just 1. I just left it there. And then I take the derivative. I have to use a product rule I have to use it twice actually, for x times 2 to the x ln of 2, and then x times 3 to the x ln of 3. So this is what I get. The red here is what I'm going to combine. Or actually, the red here is when I plug in x equals 0, I get 0. Right, so it's 0 times 1 times ln of 2 squared. And this is 0 times 1 times ln of 3 squared. Okay, so that's just going to be 0. And so I can plug in 0 for the rest. 2 to the 0 is 1, so you just have ln of 2. 2 to the 0 is 1 again. So there's 2 copies of ln of 2. That's what I have here. And then minus 3 to the 0 is 1, so that's just ln of 3. 3 to the 0 is 1, that's ln of 3. There's 2 copies of negative ln of 3. And that's going to be all over 1. Now, 2 to ln of 2 is the same thing as bringing the exponent on 2. So it's like ln of 2 squared, which is ln of 4. Same thing with 2 ln of 3. That's just ln of 3 squared, which is ln of 9. And so now because I'm subtracting the logs, I divide the inside. So this will just be ln of x over y, which will be ln of 4 over 9. And the limit now as x approaches 0 is just obviously ln of 4 over 9. And 1/2 of ln of 4 over 9 can be rewritten as ln of 4/9 raised to the 1/2 power. So this is just taking the square root of 4/9, which is just 2/3. So it's just e to ln of 2/3, which we know is going to equal 2/3, since e to ln of x is equal to the x. So our final answer is 2/3.